Okay, should we put a hidden clue in the video today?
Yeah, what?
What should be the word? What's the key word?
Alamo.
Alamo?
Remember the Alamo.
Remember the Alamo. So if somebody watches this video and sends to me through email or in person, says remember the Alamo, you get a little Debbie snack. So first person to do it. Got a few people gone today, right? All right. So with the other hours and stuff too. So. No, sorry. That's the price you pay for showing up to school. You don't get a treat. All right, fundamental theorem of algebra. Fundamental theorem of algebra says three things. They're all pretty cool. The first one you already know. Every polynomial of degree n has exactly n solutions. Or roots or zeros. Okay, whatever you'd like to call them. So to kind of write this off, you have x to the fourth power minus 16. How many solutions will that have? 4. Okay, they might be imaginary, they might be real, but it has 4. It also says that every polynomial, the coefficient of a, and solutions of c sub 1, c sub 2, c sub 3, and c sub n can be written of the form p of x equals to x minus c sub 1 times x minus c sub 2 times x minus c sub 3 times x minus c sub n. Which is short for saying that every single polynomial can be written in factored form. Now it's possible that when you multiply this all out, you just come up with, say, x to the nth power, and it's possible that you might say 4x to the nth power, 8x to the nth power, so you might have to have a coefficient out front in order to create that number. We'll see what that looks like later on. Finally, it says if p of x has a solution of a plus bi, so this is imaginary, then you must have another solution that is also imaginary. And that solution would be a minus bi. So you have a plus bi and you have a minus bi, otherwise known as the conjugate. Okay? Those are the three things. Abstract algebra. It's one of the classes you have to take if you're going to be a math major. My daughter kind of broke some news to me the other day. She's decided now to become a math major. Chances are that'll change, but who knows? Maybe she will. She's also going to get a degree in physics, and she hopes exercise science. So those are the three things she's shooting for. If she becomes a math major, she's going to have to take this class, which is abstract algebra. This is usually the class that people stop being math majors with. Okay, they get to this class, they can't pass it, they drop out. Okay. Very tough class, but in this class, you learn the proof behind why the fundamental theorem of algebra actually works. It's very, very, very complex. It is not easy stuff. Took the professor about 2 months in order to show us how to do it, prove it. Yeah, we're not going to show you the proof, but those things you know. N solutions can all be factored, and if you got one imaginary solution, you got another. That's nuts and bolts of it. Let's put it in practice. 3 problems today. You're going to start by identifying the total number of complex solutions. You are also going to identify the total number of real solutions, the number of imaginary solutions, the possible number of positive real solutions, the possible number of negative real solutions, the possible rational root choices. You're going to list all the solutions, and you will write it in factored form. I'll write those for you on your test. You have these things written out for you on your assignment as well. How many complex solutions are there? 4. The complex solution consists of the real and the imaginary together. You know that there's going to be a total of 4. Okay, that's what we've got. I want to determine the number of real solutions. I'm going to focus on the number of positive real right now. The number of positive real. How do I determine the number of positive real solutions? What do I look for?
How many times it switches from positive?
Yeah, how many times does it change here? So there is one positive real solution. How do I determine the number of negative real?
Negative.
Yeah, p of negative x, which is still positive x to the fourth minus 16. How many sign changes are there? 1. So there's one positive real and there's one negative real. Okay? If there's one positive real and there's one negative real, how many total real are there? 2. Somebody last hour said 2 or 0. Could there be 0 real solutions if there is one positive real and one negative real? See how that's not an option? Okay, so 1 and 1 for sure makes 2. So you know that to be 2. Okay, if there are 2 real solutions and a total of 4 complex, then how many imaginary are there? 2. Before this even starts, before we even work with this problem, you already know exactly the output and what it's going to be, which is pretty impressive. The rational roots are going to be your p's divided by your q's. 1, 2, 4, 8, and 16, all of those divided by 1. Notice that our rational roots are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. Okay. You now have 2 options. You can either try one of those solutions or you can try to factor it. Do you see how that factors?
X squared plus 4x, or yeah, x squared plus 4 squared.
Good. What are 2 of my solutions? Positive or negative 2. That comes from this piece right here. You have 2 more that are going to be right here. I'm going to set that equal to 0. X squared plus 4 is equal to 0. As I subtract the 4, I get x squared is negative 4. I solve by taking the square root of both sides. What do I get? Yep, because it's squared, you have 2, so it's plus or minus 2i. Look at what we just did. We found positive and negative 2. One of them is negative and one of them is positive. That makes a total of 2 real solutions. We also found 2 imaginary solutions with positive and negative 2i. That creates a total of 4 solutions that we found. See how it all lines up exactly how we anticipated? That's pretty neat. Finally, we write it in factored form. And the factored form is p of x is equal to x minus 2, x minus negative 2, x minus 2i, x minus negative 2i. Now, you don't have to write minus the negative. You don't have to do that at all. But what you do need to, I want you to understand that the fundamental theorem of algebra says you can write it as x minus. So this will be an x minus 2 and then an x plus 2. X minus 2i and x plus 2i. That's factored form. Everything factors. Questions? Okay, flip over to the next side. What I would like you to do right now is work with a partner or on your own. I'd like you to try to come up with those. Actually, you could do the rational roots as well. Don't actually find the solutions, but start to list the other pieces. I need to push the students along the way.
Recording. Make sure he's okay.
There's too much.
Just let it quick. Oh yeah. What? He's still recording. Yeah, he's still recording. Yeah. Have you never seen the videos? They can hear everything.
Oh, he is recording. What's in
They
that?
can hear Connor in the video.
Ben, let's come up with these. Okay. So there's three complex. Positive real, 0. Because there's no switch. Negative real, so it's negative and negative. It would be 1. It would be 1. Real, 1. Imaginary. Very good. Wouldn't it be 1 real?
Are we done? There are 3 complex solutions. I look for positive real. I see that there are no positive real. There should be 1 negative real. That means that there is 1 real solution. So how many imaginary will there be? There are for sure 2. My rational root choices, I have a 1 here. I have 1, 2, 4, and 8 here. So I have plus or minus 1. I have plus or minus 1/2, plus or minus 1/4, and plus or minus 1/8. Those are my options. Any questions on those? All right. Do you see how it factors? Oh, nobody sees? Should we see this as a sum of 2 cubes? Sum of 2 cubes. Okay. What do you multiply 3 times to get 8x cubed? 2x. What do you multiply 3 times to get 1? 1. So I square the front. I square the back. I multiply the 2 together. Is this sign plus or minus? Plus. This is always plus, then this is minus. What is the solution that exists here? Negative 1/2. Notice that our negative 1/2 is a negative real solution. That's our only real solution, which means the other 2 must be imaginary. And in order to solve that does not factor. If it doesn't factor, we need to use quadratic formula. So we have negative b, which is positive 2, plus or minus the square root of. B squared is 4, minus 4 times a is 4, and c is 1, divided by twice the a value. We have 2 plus or minus the square root of. What do you get underneath the square root sign?
Negative 12.
Negative 12. Divided by 8. What is the square root of negative 12 when it's simplified? Good, 2i roots of 3. Because you could take out the square root of negative 4, you get 2i. And all those 2, 2i, and 8 are all divisible by 2. So you could write it as 1 plus or minus I roots of 3 all over 2. Oh, 4, excuse me. Again, as I look at my work, I have negative 1/2 sits right there. That's a negative real, no positive real for one real. I also have two imaginaries, which make my total of 3 results. As I write this in factored form, I have P of x is equal to x minus negative 1/2 or x plus 1/2. Then I have x minus the 1 plus I roots of 3 over 4. And then we have x minus 1 minus I roots of 3 all over 4. Does everybody see and understand why this subtraction sign here, why some people might write an x minus for that one, but they might write an x plus for that one? Got to be careful, folks. Doesn't work out like that. We switch the plus and the minus there. Does not necessarily happen in the sign there. Finally, if you were to multiply this all out, x times x times x is x cubed. But look at this. It says you have an 8x cubed. So we need to put an 8 out in front. That is how it factors. Okay. All right, last example. We have our complex solutions. We have our real. We have our imaginary. We have our positive real. We have our negative real. We have our rational root choices. We have our total solutions. And we have our factored form. Okay, how many complex solutions do we have? 3. Which spot do you go to next? The positive real. How many sign changes? 3. So there's going to be 3 or 1. This is where you subtract. This is the area that you subtract. Okay, a positive real, negative real. I determine P of negative x. I get a negative 2x cubed minus 13x squared minus 26x minus 10. There are no negative real solutions. So if I have 0 negative real and 3 positive real, how many total real could there be? 3. If I have 0 negative and 1 positive real, there could be 1. So you have 3 or 1. Suppose you had 3 real. How many imaginary would you have? None. Suppose you had 1 real. How many imaginary would you have? 2. Max, you get a haircut? Connor, do it.
Did I do it?
Ty do it.
Diego.
You pay a barber? Pay a barber?
Well, what's a hairstylist?
Sure.
Yeah.
You got a tip when you do that, don't you? What do you give a hairstylist for a tip?
I just gave him the 20.
If it was $19, you give him $1 for a tip?
No.
That's pretty
It's
low right there. That's a
16.
5% tip there.
It's like $16.
Okay, so $4 tip, so like 25% tip? All right.
It's good.
Okay, there you go.
Good tip.
I'm gonna start tipping myself every time I cut my hair. All right, let's list the rational roots. We've got we've got 1, 2, 5, and 10. And up front, we got 1 and 2. So if I take 1, 2, 5, and 10 and divide them by 1, I've got plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. But then if we move on to the 2, I get 1 over 2. So plus or minus 1/2. 2 over 2 is plus or minus 1. I've already got that. 5 over 2. So plus or minus 5/2. And finally, 10 over 2 is plus or minus 5. I've already got that listed. Okay? Does this factor in a way that you can see? Hey guys, stop checking the pencils.
We're hoodlums out there. Dude, our school should get a pet tiger.
Good for you.
Oh, no way.
All right, I don't see how it factors. What number do you want to try? I already tried it. I tried 3rd hour and 6th, 7th hour didn't work.
-1.
Bad choice.
5.
Why should we not try a negative number?
Oh, wait. That's right.
No negative numbers work, right? So 1 doesn't work.
5.
5 doesn't work.
10.
10 doesn't work.
2.
2 doesn't work.
1/2.
Let's try a half.
He knows it all.
Good job, Alan.
There we go.
Diego, please be quiet.
Some people thought that you can't do this because you've got a fraction. It's not that big of a deal. You drop down the 2, and then you multiply and you get 1. Add and you get -12. Multiply and you get -6. Add and you get 20. Multiply and you get 10. Add and you get 0. So as you check this out, you've got an x minus 1/2 times 2x squared minus 12x plus 20. So we see that one of our solutions is 1/2, which is one of our positive real. How about this? Can you factor anything there? Take out a 2. 2 times x minus 1/2 times x squared minus 6x plus 10. Does x squared minus 6x plus 10 factor in a way that you can see? I don't see how. If it doesn't factor, you reside yourself to the quadratic formula. 6 plus or minus the square root of. We square our b value, get 36. Minus 4 times the a value is 1 and the c value is 10. What do you get underneath the square root sign?
-4.
-4. What is the square root of -4?
2i.
So I get 6 plus or minus 2i all over 2. 6, 2, and 2 are all divisible by 2. So I have 3 plus or minus I. So 1/2 is a rational root. It is the positive rational root. I don't have any that are negative. I only have one that's real. I found 2 more that are imaginary for a total of 3. And as I write it in factored form, I get x minus 1/2 times x minus, I need to use parentheses, 3 plus I, and x minus, parentheses, 3 minus I. If you want to distribute the subtraction sign, you can, but that's factored form for p of x. What did we say was the key phrase? Remember the Alamo?
Yeah.
What do you think the chances are that Hannah watches this? High chance?
Yeah.
90% chance? So I better record that and I better post it right away for her, huh? Then we'll do that. Okay, look at your homework real quick.
I don't have any.
Okay. So your homework, I kept it to a front page and a front page here, okay? So you have 4 problems that are similar to what we just did. And then if you flip it over, there's 2 more on the other side. You have 1 through 4 and 5 through 6. Problems 7 through 10, that's what we will do tomorrow. Tomorrow will be very short, very short, very short. Going to give you a fair amount of time to work tomorrow. And that's that.